All right, here's some questions that deal with pH and pOH. The question here says, a solution has a pH of 4.13. What's the hydrogen ion? And hydrogen ion would be the same as hydronium ion. We sort of say that those are the same in the solution. So they tell me a pH and they're looking for the hydronium ion concentration. It looks like this is my formula that I'm going to use right there. I have pH and I'm going to solve for hydronium. So the hydronium ion concentration is equal to is equal to 10. I was doing negative log pH. Hydronium is 10 to the negative pH. So in this case 10 to the negative 4.13. So on my decimals here, 10 to the negative 4.13. There we go. Ooh, that's a small number. 0.000. Are there 4 zeros? 4, I think so. 741310, etc. And I could rewrite that as scientific notation, 7.41310 times 10 to the minus fifth. Now, for sig figs, there's 2 decimal places in the pH, so I need to give 2 sig figs. So it'll only be 7.4 times 10 to the minus 5. I'm going with that one. Okay, good. There's that one. Here's another one. Calculate the hydronium ion concentration in a solution that has a pH of 9.16. Same as the question we just did. Same thing. Okay, this one. How many moles of pure sodium hydroxide must be used to prepare a liter of solution that has a pH of 1212? Oh, this is a complicated question because they're giving me pH, which from that I can directly get hydronium ion concentration, but they're wanting information about hydroxide or base. So why don't we figure out the pOH first? So I know that pH plus pOH is 14. If they give me the pH is 12.12 plus pOH is 14, then the pOH is equal to 14 minus 12.12, or that's 1.88, I think. So that's the pOH. Now, from that, I can figure out the hydroxide ion concentration. And then once I have the concentration, I can use that and the volume to figure out how many moles I have, because I have this formula. Okay, so hydroxide ion concentration is equal to 10 to the minus pOH. So 10 to the minus 1.88. Calculator. 10 to the negative 1.88. There we go. So the hydroxide ion concentration with a pH of 12.12 is fairly high, 0.0131825, etc. Now, since I'm not done the question, I'm not going to round off yet. But that's the concentration of hydroxide ions. Now, whoops, we go down a bit. So, if I have sodium hydroxide in solution, I dump that in. If I put it in water to create in a solution, it'll dissociate into sodium ions and hydroxide ions. And so what I'm getting here are moles of hydroxide ions, or moles per liter. That's the concentration of that. Now the ratio between hydroxide ions and sodium is 1:1, and with sodium hydroxide is 1:1. So the concentration of hydroxide ions and the concentration of sodium ions and the concentration of sodium hydroxide are all 0.01318. 0.25, etc. moles per liter. So now if they want to know the number of moles, I can use concentration as moles over volume. So moles is equal to C times V. And the C is 0.0131825 moles per liter times by the volume. I didn't remember that. 1 liter. Oh, that's an easy one. Times 1.0 liter. Liters cancel. So your answer is 0.0131825 moles. A nicer question would have been, how many grams is that? Because then you'd have to do one more step. You'd have to do that to figure out what the mass was, but I think they just wanted moles. Hopefully that's one of the answers. Yeah, right there. Oh, I didn't round mine to sig figs. There are 2 sig figs here, and there's 2 decimal places there, so I need to do round to 2 sig figs. So my answer would be 0.013. That's where I would leave it right there. There's 2 sig figs. All right, the last question. They say the pH of a 3.6 molar solution of hydrochloric acid. That's got to be a very, very small pH. I think that you're right. I think the exam was wrong. I think this is correct. Because if you go hydronium ion concentration is equal to 10 to the negative pH. And I can do that because this is a strong acid. Perchloric acid is, I think, one of the top dogs. So then if you go 10 to the negative 3.6, you're going to get a small number like that. Like it'll be a very strong acid. It'll be close to 0 or around 0. Let's try it. So 10 to the negative 3.6. That's very small. Did I do something wrong there? The pH of a solution. Oh. Yeah, I did that wrong, right? Because they didn't give me the pH. I thought that, like, the number was so big, I thought it was pH. But no, that's concentration. So I used the wrong formula. So they want to know what the pH is, so I do negative log of the hydronium ion concentration. So negative log of 3.6. I came up with that number on the calculator, and I thought, gee, that's very small. I thought it would be different. Okay, it is different. Negative log, where's my log button? Log of 3.6. There we go. Negative 0.55, or they probably don't have a negative one there. So the 0.56, that's the one I'd be going with right there. So you were right on that one. Okay, hopefully that helps you in moving back and forth between pH and hydronium, pOH and hydroxide, and back and forth between pH and pOH.